Okay, welcome to Pre-Algebra class. I'm Mrs. Cohen, and today we're talking about the triangle inequality. The triangle inequality is for all triangles. It can be for any triangle. And what you're doing is you're testing to see if the lengths that they've given you do indeed declare that it is a triangle. And how do you do that? Well, if you've noticed, I've drawn a triangle over here on the side. I know my drawing's not the best, but that's a triangle. And I've labeled the sides E, F, and D. And the triangle inequality states that if you add any two sides of the triangle, that measurement should be greater than the length of the third side. So, it's the sum of the lengths of any two sides of the triangle is greater than the length of the third side. So, look at here. This is the property. So I say D plus E is going, if I add these two together, it will be greater than F. If I add D plus F, it should be greater than E. If I add E plus F, it should be greater than D. Not equal to. Notice there is none of these inequalities say greater than and equal to. It cannot be equal to, or it is not a triangle. Okay? So, let's test it out and see what happens. So I'm going to give you a couple of examples. And we'll just say that if I give you the measurements 15, 22, and 34, are these the three sides of a triangle? Well, you immediately begin to add them up. So you'll say 15 plus 22 is greater than 34. Is that true? 37. Yeah, that's true. So that one works. And then we're going to say 15 plus 34 is greater than 22. Yeah, that's true. 49 is greater than 22. And then we're going to say, which one have we done? 22 plus 34 is greater than 15. Well, obviously that's true. That's going to be 56. So, you do the quick triangle inequality and you say, yes, these are the sides of a triangle. It fits the triangle inequality. Now that takes us to this one. 14, 35, and 21. So we're going to start off and we're going to go 14 plus 21 is greater than 35. No, it is not. Because 14 plus 21 is 35. 35 is not greater than 35. It equals 35, but it is not greater than 35. Therefore, these are not the measurements of a triangle. It must meet the condition of all three sides. You can't have one situation or two situations that work and the other one doesn't. When you compare all three, like we did previously, they must all be greater than the third side. Alright. That's where it's the easy part. Now we have a word problem. And it says, your house and two friends' houses do not lie on a straight line. Three people, not a straight line, triangle. It is 13 miles from your house to one friend's house, and it is 19 miles to the other friend's house from your house, because you are the pivotal point. So we're going to identify 13 miles and 19 miles. What can you say about how far apart your two friends' houses are? Question mark. So let's draw the triangle. So here's my house, and this way is 13 miles. And then this way is 19 miles. And this is my house. Friend 1 and friend 2. And then we want to know the distance here. We're not going to be able to solve the distance. This isn't a right triangle. We can't assume that. Could be, but we don't know that. It doesn't give us any indication that it's a right triangle, or we'd use the Pythagorean theorem. So we have to use the triangle inequality. Well, we have to come up with the two differences. So we know the triangle inequality says that the addition of two sides has to be greater than the third side. Alright, so the first thing we're going to do is we're going to say 13 plus 19 equals 32. Okay, so can it be 32? No, because it's going to equal 32. So it has to be, x has to be less than 32. That's one condition. You have to have two conditions. So what am I going to do to the other? I know that it's less than 32, but I have to put the other stipulation on the other end. What does it have to be greater than? What are we going to do? If we add to find the least it can be, the least amount all the way up to what it cannot be for the third side, what are we going to do to find out what's the smallest number that can be between the two distances? We're going to subtract. So we're going to say 19 minus 13 is equal to 6. Can it be 6? No, because then we would have 6 is equal to 6. So this has to be x is greater than 6. Now I want you to look at this, and this is not in the book. This is a compound inequality. We can rewrite this showing what the limitations of the distance between my two friends' houses are. What's the limitations? What can it be and what can it not be? Well, it's called a compound inequality. We write x in the middle, and x has to be less than 32. And it has to be greater than 6. Compound inequality. X is greater than 6. X is less than 32. So any distance between 6 and 32 will work, and it will be a triangle. And that's why I can find out the distance. This is a compound inequality. Notice the directions, the arrows are going in the same direction. I could write it this way. 32 is greater than x, which is greater than 6. It's the same thing. And that will satisfy the distance and the triangle inequality. And so now I have what the potential distances are. Can't assume that it's a right triangle. Doesn't say that. So you have to assume that you have to use a triangle inequality. Bring to class tomorrow 2 things that you learned about the triangle inequality and 1 question that you still have about the triangle inequality. Have a great day, and I'll see you tomorrow.